Hey guys, let's look real quick at lesson 54. 54 is going to be polar coordinates. All right, if I've got a coordinate plane and I have a point over here, and let's say this point right here is 4 comma 3. And let's say I have this point down here, and this point is -3 comma -3. Good. All right, remember that we would say this is my x-axis and this is my y-axis. All right, and so this is 1, 2, 3, 4 measures out, and this is 1, 2, 3, and so over here 1, 2, 3, and 1, 2, 3, and that gets us over there. Okay, so this right here is how we've been used to writing these, how we've been used to recording these. When we look at a rectangular coordinate, all right, with this, we're going to look, instead of looking at x and y, we're going to look at right and up. And so there's going to be right and negative right, up and negative up. All right, so as I look at that 4, 3, think about it, it's 4 to the right, so it's going to be 4r, and it's 3 up. So I've got that plus 3u. All right, this one, however, is 4 to the left, right? So we're going to call this, not 4, it's 3. So we're going to call this one negative 3r. Okay, and then this one down here, instead of going up, it's gone down, right? So this is going to be negative 3u. All right, if I do a point over here, and let's say we do this point and we put it out here at 5 on the x-axis and -2 on the y-axis, this point right here, we're going to come 5 to the right, but then we're going to go down 2, so -2u. All right, so that's taking these and writing them in a rectangular coordinate form. All right, another way that we can look at things, we're going to look also now, these are rectangular coordinates. Now we want to look at polar coordinates. Okay, polar coordinates are going to look kind of like this. Say if I put this 4 and 57 degrees. All right, this is going to be referring to something that I have graphed here, and I have this line. All right, and this angle right here is 57 degrees. And my line right here is 4 units long. And so this point, this right here, this polar coordinate, that is the coordinate of this point. All right, we always start off heading due east. Okay, so there's due east. Well, this is telling me I go 57 degrees from due east and out 4 units, and that's what's going to get me to that point. Okay. If I've got another point, say this point over here, where is this point? Well, I'm going to say this point, if I were to draw a line to that point from my origin, it's going to be 7 units away. And as far as from due east, I'm going to come around 230 degrees. All right, so this is written as 7 and 230 degrees. Okay. So we've got this idea, this is a vector, and this vector is going to have a magnitude. All right, so this is a magnitude. All right, and that's dealing with length. All right, and then it's also going to have an angle over here, which that deals with direction. Okay, so if we're given this this vector 4 and 57 degrees, all right, and we're given that, we can change this from this polar coordinate, into into a rectangle coordinate using sine, cosine, and tangent. Okay, so let's see. We've been given this, and they're asking us change to rectangular coordinates. All right, so I'm going to take this and I'm going to graph it. This is not an exact science right here. This is just a picture to help you out, okay? So I know this is 4, the length here is 4. I know this right here is 57 degrees. All right, so think about the fact that I can form this into a triangle, right? And remember our sine, cosine, and tangent? And so this over here would be my opposite side, and this is my adjacent side. So I can use sine, and the sine of 57 degrees is going to equal the opposite side over 4. So now I multiply both sides by 4, so I'm going to say 4 times the sine of 57 degrees equals that opposite side. So then I'm able to calculate that and find that this equals 3.36. So this side over here, I now know is 3.36. All right, as far as that adjacent side, I can take my cosine of 57. All right, Oscar had a hold. Okay, so this is going to be the adjacent side over 4. Again, finagle things around, move things around as we need to, and we're able to find that this adjacent side is going to equal 2.16. So as I write this then in my rectangular form, I've got 4 at 57 degrees, polar form, equals 2.16 R plus 3.36 U. Okay? So I've taken that and changed it from polar form to rectangular form. All right, let's look at one more. Give the rectangular form coordinate for 7 at 230 degrees. All right, drawing myself a little picture. I'm going to have this over here. I know that this is 7. All right, 230. I've got this 230. I need to subtract that 180 to begin with, right? Okay, so I'm finding there that this right here is 50 degrees. All right, and so I'm wanting to find this side, and I want to find that side up there. All right, as you do this problem, chances are high that they're going to put some other letters in there for you instead of O and A, just to make things a little challenging. Let's say that this is C and this is D. Notice that C is my adjacent and D is my opposite. Okay, but I can do just like I've done before. So this is going to be that the sine of 50 equals the opposite, which is D, over 7. So 7 times the sine of 50 is going to equal D. So D is going to equal 5.39. Okay? And the cosine of 50 is going to equal C over 7. You work that out, and you're going to find that C equals 4.48. All right? So now I know that D over here is 5.39. And I know that C over here is 4.48. So for this vector, 7 at 230 degrees, the rectangular coordinates are going to be negative 4.48 R minus 5.39 U. Okay? It's a little funny, but it totally kind of makes sense when you just work it out. Okay? That gave us lesson 54.